Hi Matthew, this is Unit 7, Lesson 13, and we're going to be using radians. This is really the exact same lesson you did last Monday, where we were using degrees to find sector area and arc length. Now we're going to use radians to find sector area and arc length. So let me first explain the two formulas before we get started. So the sector area in radians is equal to the area is 1/2 r squared times my theta. And my theta will be in radians. Pi over 2, 3 pi over 4, 2 pi over 3. It'll be a radian. And then we also have arc length. And we have a formula for that when we're in radians instead of degrees. And my arc length, abbreviated with the lowercase s, just like last week, is my radius times theta. Again, theta is in radians. And you might wonder why we have a different formula for radians versus degrees. It's actually the exact same formula. So out to the side, let me just mention where these come from. So let's go back to last week. When I was working with area in degrees, we established that our formula was the portion of the circle, so theta over the entire circle, 360, times the area of a circle, pi r squared. So now let's change my units to radians. So now let's change to radians. So if I'm going to change this to radians, my theta is no longer going to be divided by 360. The entire circle is no longer 360 degrees. If I change to radians, it's now 2 pi radians. The entire circle is 2 pi radians. And I'm going to still take that times the area, pi r squared. So again, this was the portion of my circle that I wanted to find the area of. This is still the portion of my circle that I'd like to find the area of. But conveniently, now pi cancels, and we have theta times the radius squared all divided by 2. So we like to rearrange that and write it as a coefficient of 1/2 in the front, r squared's next, and theta we just stick at the end. That's exactly the same formula. So that's why our sector area in radians, we use the formula 1/2 r squared theta. So let's take a look at our arc length. Last week in degrees, if you remember, our formula for arc length was the portion of my circle, so theta over 360 was the part of my circle I was trying to find the arc length of, and the arc length is around the outside, so I multiplied by the circumference, which is 2 pi times the radius. So now when I do my simplifying, when I change to radians, so when I change my work to radians, it's no longer out of 360 degrees. It's now out of 2 pi radians. So this becomes theta over the total circle, which is 2 pi radians. That's the portion of my circle times the circumference. Well, now you can see how my 2 pi's cancel, and I'm left with theta times the radius. So we write that with the radius first, and that's why the arc length in radians is s equals r times theta. So let's take a look at our problems here. Let's use this first problem 3-2 as my example. So this will be my first example. My theta is 3 pi over 4, and my radius is 12. So let's go ahead and set this up. Let's find the area first. So the area is now equal to 1/2 r squared theta. So my area is equal to 1/2 12 squared times 3 pi over 4. Remember with PEMDAS, I have to do parentheses first, anything inside parentheses, and then exponents. So I do need to square the 12 before I do anything else. So don't cancel the 1/2 and the 12 to 6, for instance. So that's 1/2 of 144 times 3 pi over 4. So you can think of your math in a lot of ways here. The 144 times 1/2 gives me 72. This is really over 1. And when I divide 144 by 2, I get 72. And so I really have 72 times 3 pi all over 4. So I could think of my area as 72 times 3 divided by 4 would give me 50. I'm looking at my calculator here. 54 pi in units. Oh, that's a 54, sorry. I was messing with my calculator and wasn't looking carefully. So it gives me, when I multiply 72 times 3 divided by 4, I get 54 pi units squared. And you can also multiply in by pi if you wanted to. So you could also write that 54 times pi is approximately 169.7 units squared. And that would be a good answer too. So now let's talk about our arc length of this. So remember, the arc length is this distance around the outside. My sector area was the blue. So now I'm just doing this length of this arc around the outside. So the portion of my circle times my circumference, remember, simplify down to the radius times my theta. So in this case, it's 12 times 3 pi over 4 radians. Well, this is 12 over 1. So I would cancel. My 12 divided by 4 is 3. So that's really 3 times 3 pi, or it's really 9 pi units, because this is just a perimeter, like a distance or circumference. And that would be a great answer. Or if you want to multiply by pi, you can. 9 times pi is approximately 28.3 units. So let's take a look at going to the practice. Well, I want to mention, so you're pretty much ready. Your homework for Unit 7, Lesson 13 is numbers 1 through 5, I believe. And I just want to talk about a couple of them. So let's talk about 1B to start off with. Let's read this one together. It says, find the arc length of an arc with a central angle of 5 pi over 6 radians, that's my theta, and a circumference, ooh, that's not my radius, a circumference of 12 units. So in order to use my formula, there's a couple ways to do this problem, but in order to use my formula, remember arc length is equal to theta times the radius. So if I'm going to use that formula, I do need to figure out my radius. So if the circumference, which is 2 pi times the radius, is equal to 12, then I know that the radius, if I divide both sides by 2 pi, I know the radius, and 12 and 2 simplify by a factor of 2. I know the radius I could say is 6 over pi. Should you divide that on your calculator? You could, but I wouldn't. And let me tell you why. When I plug that into my formula, my pi's are going to cancel. So actually, I find it kind of handy just to leave it like that. But if you wanted to divide it on your calculator, you could. But let's take a look at the problem now. So my arc length is theta times my radius. So my theta in this case is 5 pi over 6. So 5 pi over 6 times my radius is 6 over pi units. So this is what I was mentioning earlier. My pi's are going to cancel, so it was kind of handy not having it in decimal form, because these guys cancel, my 6's cancel, and it looks like I'm just going to get 5 units. If I had had that in decimal and I rounded, before I plugged it back in and you multiplied by pi, which is a decimal, you might get a slightly different answer. And when I say slightly, I'm not sure what it is, but it would probably be like 5 point something very small, or 4.99 something very a larger decimal. So something really, really close though to being exactly 5. But I will say if you went to decimals, it would be something different than 5, I think. So you guys, let's take a look at something in 2. Let's pick out, for example, B. And it says in this one that my circle's radius is 10. And then it says to find the area of a sector. So this is an area problem. An area of my sector, I have to remember, is 1/2 my radius squared times theta. That was my formula. So let's try this. So my area is 1/2 my radius, which is 10 squared, times my 3 pi over 4. So remember, you have to do the 10 squared. You can't cancel anything before you get your 100. So it's really 1/2 of 100 times 3 pi over 4. So now you have lots of different ways you can simplify. Just looking at this for me, I see the 4 and the 100, and I think, it's 100 over 1. They simplify. So for me, I'm seeing 25 times 3, which is 75 pi over 2. I'd like to remind you guys that's the same thing as 75 over 2 just times pi. Either way, pi, if it's up here, you can think of it as over 1. Either way, pi is in my numerator, 2 is in my denominator, and 75 is in the numerator. So however you want to think about it, you could leave your answer 75 pi over 2 units squared, or you could multiply it out. And if you do that, you could divide by 2 actually. I was going to mention you could write this as 37.5 pi units squared as well. That's your 75 divided by 2. You could also do your 37.5 times pi and get a different decimal. I don't have that right in front of me right now, but you could calculate that on your calculators. So I do want to mention on C and D, sometimes, and we've already seen this was last week when we were converting from degrees to radians and radians to degrees, sometimes our radians don't have pi. It's nothing to be worried about. It basically means pi is already multiplied in. So I just want to spend a moment with you to talk about what this means. So if I could draw our unit circle, remember our circle goes from 0 degrees all the way around to 360 degrees. And when I'm starting to think in terms of radians, my circle goes all the way from 0 degrees to 2 pi radians. So if you remember your assignment Friday, you were taking that circle and you were writing your radians all the way around your circle. So if you want to grab out that worksheet, it was the 3rd page of our notes last Thursday and Friday. But just real quickly, I'm going to write around my circle, 90 degrees was equal to pi over 2 radians, 180 degrees was equal to pi radians, and 270 degrees was equal to 3 pi over 2 radians. So when you're looking at C and D and they just say 1 radian or 2 radian, those are also on this diagram, but I need to do some calculations. On my calculator, if I take pi, which is 3.1415, divided by 2, I get approximately 1.57. Pi, we know, is approximately 3.14. If I take 3 times pi divided by 2 on my calculator, I get approximately 4.7. And finally, 2 times pi, I get approximately 6.28. These numbers I just wrote around my unit circle are in radians, but they no longer have pi in the number because I've multiplied it in. So in C, when you see 1 radian is somewhere in between 0 radians and 1.57. So for example, this would be 1 radian. So when you see 2 radians, it'd be located somewhere in the 2nd quadrant. 3 radians would also be in the 2nd quadrant. 4 radians would be in somewhere in this 3rd quadrant. 5 radians would be in the 4th quadrant. 6 radians would be in the fourth quadrant, and 6.2 radians is when you've gone all, 6.28 radians, sorry, is when you've gone all the way around your unit circle. So don't be thrown off. That was just a long little bit, sorry, but don't be thrown off when you see radian measures without pi. It's just pi has been multiplied in. So take a look at the next page. So I feel like 4 and 5, you guys are good with these. You're converting to radians, you're converting to degrees. Awesome. Let's take a quick look at 3. So it says each circle has a shaded sector with a central angle measure in radians. What fraction of the circle is each sector? There's a couple different ways to think of this. Let's take a look at circle B. I just want to give you one way to look at it. So if you think about half the circle having 180 degrees or half the circle being pi radians, then when I look at this pi over 12, I'm thinking to myself how many degrees that would be. And so I could, if pi is 180, in my head for this right here, I can think of it as 180 divided into 12 parts. And I can divide 180 by 12 and I get 15. That's my 15 degrees. This little tiny sliver is 15 degrees. So what I'm really trying to find out is what portion of the circle is 15 degrees. Well, I know my entire circle, the whole circle, has 360 degrees in it. So what part is 15 degrees? Well, what part of it? 15 degrees out of 360, and that reduces to, I believe, 1 over 24. So it's 1/24th of the whole circle. There is multiple ways you could look at this. Another way to look at this, and I'm going to do it out to the side, is just to stay in radians. Your circle has a total of 2 pi radians. So if your little blue section here is pi over 12 radians, if you divide that by 2 pi, you can find out what part of the circle it is. This is commonly a mistake, and I call this the triplex. Kids see pi, divide by 12, divide by 2 pi, and they see distinctly 3 levels. There's not 3 levels here. There's only 2 levels. There's a numerator and a denominator. This is my numerator. This is my denominator. So what is the 2 pi? The 2 pi is also in my denominator. The 2 pi, when I divide by 2 pi, I'm really dividing pi, this pi in the numerator, I'm dividing it by 12, and I'm dividing it by 2 pi. So another way to think about this, remember back in junior high, instead of dividing by something, you can multiply by the reciprocal. So you could also think of this as pi over 12. Instead of dividing by 2 pi, I'm going to flip it. It's 2 pi over 1. So when I flip it, its reciprocal is 1 over 2 pi. And again, you can see that it's pi over 24 pi. This is a very popular mistake even at our Math 2 Enhanced level. When students see 3 levels to a division problem, they get confused about where things go. But the 12 and the 2 pi are both in the denominator. I'm dividing by 12. I'm also dividing it by 2 pi. And you can see when you simplify this, the pi's cancel. And I do get that same 1 over 24 I got when I used the degrees. So it just kind of depends. I showed you the degree way first because you don't end up with that triplex situation. If you're good with dividing it by 2 pi, then divide your radians by 2 pi. And there's also other ways to think of it as well, besides just those 2 ways. So finish this up, and then you'll 1 through 5, and the practice, I believe, is what you upload in Google Classroom. Thank you very much.